Come on in, Ted.
Okay.
Hi, this is Owen Driskill from Roane State Community College. I'm here with my colleague Ted Strike, one of our professors. We're starting our second Periscope broadcast today. Hope you have a chance to watch if you have a chance to tune in. You may wonder sometimes what our professors do during the summer. Some of them go on vacation, some of them go scuba diving, some of them travel to other countries, and every now and again some of them participate in NASA missions that change our understanding of the solar system, and that was Ted's summer. So I'm going to scoot out of the way and bring Ted in right here.
Okay.
And he's going to talk a little bit about the Pluto flyby. Ted, just start off a little bit with what the Pluto flyby was.
Well, back in the early 1960s, we set off to explore the solar system. We had a solar system of 9 planets to explore. The Earth, of course, we were on one of them, and we went beginning with the 1962 flyby of Venus by the Mariner 2 spacecraft. We, one by one, began to explore these worlds, and the last one until now was Neptune in 1989. And so there was this big gap, and in that the most distant world, the final world of that initial exploration, was unexplored, and so it was very exciting to finally see this mission that explored Pluto up close for the first time and made it into a real place that we could see and explore.
Ted, if you don't mind, talk a little bit about how you got involved in the Pluto flyby.
Sure. I've always enjoyed working with NASA images and space images in general, whether it be from a telescope or from a spacecraft, and enhancing them. And I've done some work with the images taken during our first encounter with the planet. When Voyager flew by Neptune, I'd done some work with some images of its big moon Triton, which is thought to be a lot like Pluto, very similar. In fact, it's thought to be captured by Neptune, but it was once a world similar to Pluto. And I got an email from the team asking me to come and present on my work at a science team meeting back in, I got the email in 2009, the meeting was in 2010, and ever since then I have been involved with the project on some level, and then they asked me to come up and help in encounter time, and so I said sure.
So what was it like for you? I mean, you've been sort of helping with this in some ways for almost 5 years. I mean, what was it like to just describe the scene for me, to be there as this is actually happening and you're getting these first images? What was the scene like there?
It was in the days leading up. It was surreal. There would be every day or two maybe a new image, and each one was a little sharper, a little closer, and we felt a little bit closer to being able to make some kind of sense of what we were seeing. And so we'd all gather around our laptops and the monitors for the image to come, and then we'd all try to interpret what it was, and then we'd meet once a day to discuss the results, both from images and from other instruments. And to see this being done in real time, the interpretation of a new world in real time, and not to just hear about, in a book, the work that people had done, hear the technical details, but to see the emotion on people's faces. I've been involved since, like I said, 2009 in some way, but a lot of these people have been involved for more than 2 decades in making this happen, and to see it come to fruition, it's something that really is a one-of-a-kind experience.
What were your emotions like as you're there in the sort of the ground zero of this mission?
Well, first of all, when I was watching the Voyager 2 Neptune flyby on television, they had a show called Neptune All Night on PBS where you could watch the results come down, and my mother made me go to bed. I was 10 years old, and she said, you'll thank me for this someday. Well, no. And what I told her was, well, okay, but I'll be there next time. And of course, by next time I meant Pluto. And so for me personally to actually, that was my little kid dream, was to be involved in some way in the exploration of the next planet, Pluto, and to have that actually happen, I still think I'm going to wake up and this is going to be, not real. And then to see a world, Pluto is, by at least surface area, the largest unexplored thing in the solar system, and to see it be a fascinating world with diverse features and and terrain unlike where we've seen anywhere else, possible nitrogen glaciers, all sorts of fascinating things, just really was icing on the cake.
What was the most fascinating part for you?
The most fascinating part, I think, was probably the fact that we were all debating what Pluto would look like and comparing it maybe would look like, for example, Neptune's moon Triton, and we kind of talked about some other worlds in the solar system, but it really doesn't look like anything else. It is a new class of world, and it tells us that the solar system is more complex. We always thought that small world like Pluto and its large moon Charon or Charon, depending on who you talk to, the pronunciation varies. We've explored other worlds outside that were moons of the giant planets, and we always thought that maybe they were active because of the gravitational interaction with the giant planets. But for these relatively isolated worlds to be very active worlds tells us that that the solar system is more complicated than we ever imagined, and so it makes me want to see more of these outer solar system worlds. Pluto is, you used to think of it as this isolated interloper on the outside of our solar system, and now we know it to be one of the largest of many big planety worlds out there.
Is Pluto going to feel bad that you called it an isolated interloper?
Well, I don't think Pluto has a lot of emotions. Of course, it does have a big heart-shaped feature on it, so maybe it does. But Pluto is not, I don't think it's going to care, but it used to be that the solar system had the inner terrestrial planets, like the Earth, there was Mercury, Venus, and Mars, and then the asteroid belt, and then the 4 gas giant planets that don't really have a solid surface, Jupiter, Saturn, Uranus, and Neptune. And then there was funny little Pluto out there that doesn't orbit even in a round orbit. In fact, it spends a little bit of time inside Neptune's orbit. It was there from 1979 through 99 or so, and didn't really fit in either category. It's way too icy and small to be one of the terrestrial planets, but it's definitely not a gas giant. So, what is it? And we now know that it's the brightest and one of the innermost of a whole class of worlds that we're just beginning to explore on the edge of the solar system.
Now that we've kind of gotten past the Pluto flyby, what are you working on now? What's sort of your next project that you're interested in?
Well, it's a little hard to get past the Pluto flyby because probably about, depending on how you count it, 95% of the data is still on the spacecraft. It was a compromise between getting there quickly and taking a big antenna, and since it doesn't really have anything to observe right now, it can spend its time transmitting data, and beginning in September we're going to see the best images come down. We haven't even seen the closest up images it took. The best images we have now are highly compressed versions of things at about 400 meters per pixel, to where you would basically Neyland Stadium, for example, would be a few pixels across, which for those not in this area, if anybody's listening, is a very large college football stadium that seats about 100,000. Some of the images are as good as 80 meters per pixel, which would mean that you could detect the actual field itself inside the stadium, and much smaller objects. So really, right now, this project has a long way to go in terms of just studying Pluto, and then hopefully, if we get funded, we'll be exploring another much smaller object in the outer solar system in either late 2018 or early 2019.
And so this kind of the September images, when they come in, will that be sort of like another round of just sort of fascinating new opportunities for you?
Yeah, there's a lot of images that close-up that we haven't seen at all, and even the areas that we have, they're essentially JPEGs that we have that were transmitted early to make sure that should something go wrong, we had something on Earth, and so that we had something to show to the press. In fact, they were called the New York Times set because we knew the press would be interested right away. But during Close Encounter, New Horizons did not have a steerable antenna. Having an antenna that can move around is one more thing that could go wrong. But a downside to that is that it couldn't be, other than instruments that study the solar wind that don't really have to be aimed, it couldn't really be taking data and observing things at the same time as transmitting data. So any time spent transmitting data was time you weren't spending observing Pluto. And so very little data was sent back during that time for that reason. So we are really just at the very tip of the iceberg with this.
So it's going to remain an exciting project for you probably over the next several months.
Probably for the rest of my life, honestly. I mean, you know, I've still worked with images from the Voyager flybys of the 70s and 80s of the planets, and, you know, I don't anticipate that New Horizons images will disappoint. I think I'll be working with these for a very, very long time.
All right, Ted, is there anything else you'd like to add just about your summer and your experience participating in the Pluto flyby?
Just that it was amazing to see what a team of determined people who really want to make something happen, that's a positive thing, can pull off. I mean, I was amazed to see the teamwork. You know, there's a lot of competition for resources and who's observing things when, and trade-offs with how close to fly by and how that came earlier with the trajectory and all sorts of issues that could have caused trouble. And to see the way that the team interacted and all worked together towards a common goal was really inspirational.
That's a great lesson for our students as well. Well, Ted, thank you very much, and thank you for sharing.